Hello guys, in this video I'm going to show you how to solve next letter problem. This one is in modified binary search pattern. So given an array of lowercase letters sorted in ascending order, find the smallest letter in the given array that greater than given key. Okay, so pretty similar with the previous problem, which is ceiling number, right? But in this case we're dealing with characters, not number. But actually we can consider character as numbers as well. So if we do something like a smaller than b, return true, because in alphabet systems A comes before B, right? Same here. C, A, less than C, right? Or A equal to A, right? So actually it can be considered a number as well. We can compare just like number in JavaScript. Okay, assume the given array is a circular list, which means that the last letter is assumed to be connected with the first letter. This also means that the smallest letter in the given array is greater than the last letter of the array. Wait a minute. The smallest letter in the given array is greater than the last letter of the array. Also, the first letter of the array. Okay. So, okay, given this array, this set of characters, right, and the key F, what is the smallest one that greater than F? Smallest that greater than F, right? So it cannot be F. Firstly, our inputs is sorted order, right? A, C, F, H. In which A is less than C, less than C, less than F, F less than right? H, sorry. Okay, so the smallest one that greater than F should be on the right side of F, right? Which is H in this case. But yeah, to find it's just like find the ceiling of a number in the last problem. We've probably want to do the same logic as binary search, but maybe there's some modifications, minor modifications. So let's try to run it manually, right? So we have left and right. Left here, right. Let's say this one. Okay. Okay. We have left and right. We find the middle, right? Which is in this case. Make it clear. Left. Left is this character. Left. This one will keep track of the index of left pointer. 0 left, and right is this guy. 1 2 3 0, 1, 2, 3, right? So middle will be 3 divided by 2 equal to 1.5. This round to 1, right? So here is a middle, right? Okay, so we compare the middle with the key, right, to determine which side the key should be located at. Right? So obviously key is greater than C, so it should be on the right of C, because when a sorted array is sorted in ascending order, so it should be on the right of C, which is all the way from F to H, right? So we reassign the left pointer to F, which is the one that's not right next to middle. Okay, so middle left is reassigned as 1.1 is 2. Okay, we go into another iterations, right? Same logics. Middle is 3, 2, but plus 3 is 5. 5 divided by 2 is 2.5. Round to 2, which is F, right? So middle is 2, same as left, right? So because here middle is equal to F, right, which is our key, so the smallest letter that greater than key must be right next to middle, right? On the right side next to middle, right, which is H, right? So let's run to this one. Let's do it quick with this one. H, right? Same here. For middle will be C. We compare key with C. H is greater than C, so we limit our space. Left here, left is F and right is H. Middle is F, right? Compare compare H with key with middle is greater than middle, so it's greater than middle, so key should be on the right, right? So we reassign, we limit our search space, right? So now left and right point to H, and also the middle, right? Because left is equal to right, so middle is the same as left and right. So H, okay, is equal, but in this case we couldn't find. So the key is equal to middle, right? So the smallest one that greater than key should be on the right side of the middle, but it's out range now, so it should be on the first one, right? Which means the last set is assumed to be connected with these. this explains why we pick A, right? So if we couldn't find the one on the right of the middle, return the false, right? So let's try to code it out. Binary search, 2 pointers, left and right. Left 0, right is chars.length -1, which is the last index, right? So as long as left is less than or equal to right, we want to continue our iterations. For each iterations, we want to find the middle index, which is left. We can do some thing like left plus right minus left divided by 2, but this could be resolved to decimal numbers, so we need to round it down, right? So middle, okay, there are our two cases when comparing key with middle, with number at the middle index, right? So the first case, keys is equal to the character at middle index, right? So if in this case we return key is at the middle, right? So the smallest one that greater than key should be the character at middle plus 1, right? We return characters middle plus 1, but if it is this is our range, I'm going to return characters at index 0. Okay. Two other cases, if key greater than characters at middle, and else key is less than characters middle. So if key greater than character at middles, it means the smallest one that greater than key is also on the right, right? When sorted array in ascending order, so we want to find on the right of key exclusively, right? And we reassign the left, right? Right is the same, left will be reassigned as middle plus 1. Okay. The other case is key less than characters at middle, which means key is on the left of middle, right? Key is on the left of middle, so we want to find on the left, right? Continue our iterations on the left, but so we reassign middle right is middle -1. Is this correct? What do you think? Is this correct? Is it not correct? Because the smallest number, our goal is not to find the index, not to find the key, but to find the smallest one that greater than key. It means if x, y, z middle, it means if key is on the left side middle, then the smallest one that greater than key can be middle, right? So we will limit it from the left to middle, right? Inclusively, right? This should be good. So okay, so we exit our loop when left is greater than right, and we couldn't find an exact, and we hadn't returned it here, right? If it had come here, we wouldn't go here. Instead, we return that way, right? So it means there's nothing in the characters array equal to key. So what does it mean? So what is the smallest what we will return here if left is greater than right? It means what does it mean? Let's say x and y here, we have left here and right here, right? So it means our key is greater than x and less than y, right? So here no, sorry, our key will greater than x and less than y. So it means the smallest number that greater than key will be number left, right? Which is y. So we return not numbers but the characters at index left, right? Okay, let's run our test. Okay, it works. So wait a minute, just not this one. Okay, no, we need the one that index. Okay, get this. Can here's turn. What's went wrong here? It seems like we get into a infinite loop. So what could be wrong here? If keys is greater than middle, so search being on the right, we reassign left, right? Exclusively. Why? What could be wrong here? Well, right. couldn't. Let's debug it. Okay. There must be something wrong here. Left and right. Okay. And middle is 1. Okay. Key is equal to that middle. Return. No. Key. Compare F with C, right? So it's on the right. Get into this one. Left is will be 2. Okay. Okay, middle is 2, so it's equal, so it will return this. Okay, there's a middle plus 1. Whoops. Middle is not defined. What's wrong here? Why middle is not defined? F key is F also. Okay, so it equal return this. H. Okay. Resolve H. Okay. Don't see anything wrong here. Oh, come on. Okay, it worked for the first case, but one of the following is not good. If it's B, key is B, there's no B here. B is right here. Let's debug this one. Okay. So, yes, okay. Middle one with key is B. So it's on the left side, right? Left side. Key is on the left side, so search space will be A to C. Will be this, run into this block. Okay. Now B. Okay, middle is 0 now. Okay. We can compare A with B. So it's on the right. So we'll run into this block. Okay. So again, you can see left right is 1. Middle is 1 also. B is less than C. B less than C. So we will find on the left of C, right? We'll reassign the, we'll run in here. So right is again equal to middle. So it will lead to infinite loop. So how to resolve these situations? What maybe the problem is here? Key equal to oops. Let's see. This is causing a problem. Okay. No. This one is causing problem. So if its left is equal to right, then middle is equal to left and right, right? So if key is less than the middle one, we will run in here. And right again is assigned middle and over again. So this is causing problem, which is we don't want. So let's this will resolve problem, I think. So lab. So for example, lab equal to right and so the middle, right? So if k is less than our middle, k is less than middle, we will limit, we'll reassign right to middle plus 1, which is right now right is here, right? So that k is less than middle, so it should be the middle, right? So we will return characters are left, so middle is the one in this guy, right? So we return characters at index left, right? This is causing problem, so okay, run it again. Okay, it works. So thanks for waiting me debugging it. So see you in the next one.